Good morning, everyone. Morning, Don.
Good morning, Stuart. How are you this morning?
Good, good. Looking forward to
Good.
this webinar.
Yeah, I'm excited about this. This is, the big story really for, there's lots of stories in FME 2021 we just released, but certainly stream processing is really one of the big ones. So in this webinar, we're not going to do demos or talk too much about FME, but we're just going to talk about, just sort of lay a groundwork for what stream processing is, what we mean when we talk about stream processing. Yeah.
Right, yeah, very high level.
Mm-hmm. Mm-hmm.
Okay, should we dive in?
Yeah, let's go.
So, well, yeah, my name is Stuart Harper, and I run the cloud group at Safe Software.
Yeah, and I'm Don Murray. I'm one of the founders, and I get to work with a great team at Safe on a daily basis, like Stuart and many others. And so, yeah, I think I'm going to turn my camera off now, Stuart,
Yeah,
just
let's turn
so in case people have low bandwidth. And yeah, so I'm going to do that.
Good idea.
There you go. Yeah, perfect. Yeah, I look better there anyway. So.
It's a while ago for me. Okay, so yeah, this is will be about 40 minutes long, 35, 40 minutes on the presentation. Then we've got some Q&A after as well, but you can answer questions at any point during this in the chat there on the right. I think we've got Mark and Steve on the chat answering questions.
Yeah.
So what are we? I mean, this is a high-level overview, but basically we are staying high level in this presentation. We're not talking about FME, our technology. We're more just talking about general trends and kind of both in the market and in the technology. So should we dive in on the kind of market trend side of things, Don?
Yeah, let's do that. So so on the market trends, so if you go to the next slide there. Yeah, so really stream processing, stream data, the market is just exploding. We've got 5G, we got cost of sensors plummeting, we got businesses more and more understanding the value of streaming analytics. So you can see in 2020, the market was 12.5 billion, so pretty fair size. By 2025, so just in 5 years, it's going to go up by a factor of 3 times or 300%. So when we talk with and we read what's going on with business systems, over half of them are looking at how do we incorporate real-time data into our business so that we can have continuous improvement and continuous intelligence to improve decisions. I mean, business moves faster and faster and faster than it ever did. So those organizations that support data streaming, that's a huge competitive advantage to them. So they really want to do stream data. So that's why people are doing stream data, because it helps them run their business more effectively. Yeah. Yeah, so cost obviously is one. The cost of hardware just continues to plummet, and with that, just the growth of sensors. We're all walking around with amazing sensors, including LiDAR now in many of our pockets. Cameras have come down, sensors are everywhere. Devices now all have sensors on them that enable them to report to you. Even you buy a fridge, it has sensors on it. So really, the sensors are absolutely everywhere. And of course, now that you have sensors and data, now there's a need for the technology to capture, and process it to help everybody get value from the data. And so, with all these sensors and the real-time data, the key is that now data is being delivered faster than ever before. And any business, if you can make decisions one step faster than your competitors, then that's a huge advantage for you. So yeah.
Yeah, nice. Okay, so that's kind of a great overview of where the market is, and I'm sure within your organizations you've seen kind of an uptake in sensor data being available to yourselves. What we'll look at now is just start to look at a little bit on the technology side of things. So the main part of stream processing is the data. So we want to start with the data. Let's look at what data looks like when it's ingested into a stream processing system. But if we step back a bit, we've really got two types of data. We've got bounded data and we've got unbounded data. So bounded data is finite and it has a discrete beginning and end, and this is typically what you associate with batch processing, that transactional data. So an example would be, sales data for an organization. This data is collected maybe daily or at the end of the week, loaded into a database, and then every week or every quarter or even every year, maybe all of them, analysis is run on that data, insights are gained and outputs created through kind of a batch process. So that data has a discrete beginning and end, which does actually makes it relatively simple to process.
Mm-hmm.
But then we've got unbounded data. So this is used interchangeably with kind of data streams, but unbounded data, I guess, is the more kind of technically correct term. So this data is infinite. It has no beginning or end, and it's typically, this is what's associated with stream processing. Now, unbounded data, typically it tracks kind of real world events. So we'll show you some more examples later, but the example at the bottom here would be a sensor gathering data on anything really, on temperature or speed or location or something like that. And this data, it doesn't stop. It just continues. It's continually recording and pulling data in. And so you can see here the kind of visual difference there between bounded and unbounded. On the left, we've got this 3-hour interval where we're doing transactions against the data in the database. And on the right, we've got this stream of data that it just never stops. It's 24 hours a day. So this kind of differentiation is really important to understand. And let's go a little bit deeper now into an unbounded data set and what that looks like. So this one, there's several things here. Firstly, although there might be a lot of data, typically data records are small in size. So usually when you're ingesting a data stream, you're looking at some kind of structured data, JSON, XML, CSV, something like that. And your individual files are probably, or messages, can we call them, are probably not larger than a couple of kilobytes, certainly not megabytes or gigabytes. But data volumes can be extremely high. Talking thousands of points a second. It really depends on the system, but you can have a large number of messages coming into the system that you need to handle. The other thing is data distribution can be inconsistent. So this is really important because obviously we're tracking real world events here a lot of the time with unbounded data sets. So let's imagine you're monitoring rush hour. Let's imagine you're monitoring moving assets like vehicles in a city. Well, at 3 o'clock in the morning, you've probably got no load hardly at all on the system because no one's driving. And then in the morning in rush hour, then you're going to have a very, very huge peak. So this is fairly consistent. And then the other thing actually is data can arrive out of sequence compared to when the event happened. And this, you need to design the system to be able to handle this. In the real world, of course, you're going to collect the data in sequence, but by the time that data's gone through a network, maybe gone through a distributed message broker system, it might end up in your application that's doing the processing out of sequence compared to when the real event happened.
Yeah.
And
So when we look at the value of of real-time data, you can see that like Stuart, we'll stick with his rush hour example. So if you're monitoring your road situation and you want to see where cars are backing up, obviously if the faster you're processing that data, the more you can make that time critical situation, deploy tow trucks, whatever other vehicles you need to do, whatever you need to do, the snow plows, to try to keep that road open, to maximize the number of cars that can get through. As time goes on, your ability to react goes down. So you can see, if you can react in minutes, you're still there. By the time you're hours, now you're really looking into, reports, looking at trends, you're looking at historical. So we're not saying that historical doesn't have any value. We're just saying that the individual points at that time don't have as much value. Clearly, historical is great for trends, determining when you want to expand your network, your road network in this case. But the ability to react and to make those time critical decisions really depends on how quickly you process this data that's being collected. Yeah.
We've talked a little bit about what underpins stream processing in terms of what the technology looks like around data streams. Let's have a look now, where are these data streams coming from? And this next slide is it was interesting for me, this one, Don, because I think when we started this, both of us, we understood the last category quite well.
Yeah.
But the other two were maybe more of a little bit, certainly the top one, a little bit of a surprise in terms of an event stream there.
Yeah. And there's just more and more. It's kind of interesting, like, and this is no way a definitive list. This is just some samples. There's just so many more event streams, and as the systems come online and add real-time capabilities like we've had, you're going to see more and more organizations identifying more and more of these event streams as they really start to maximize the value of everything coming in. So it's just absolutely huge. Yeah.
And some of the ones that you might not know what they are, like click streams and social computing. That's all around like tracking clicks in the web browser. Like if you go on a site, some companies, they track every single mouse location and click. So that's a potential event stream, and even logs as well. This systems produce so many logs, and logs are really an event. That's what they are, and most logs just go, they just go to the wayside. They're never looked at, they're never processed. So, even getting insights from logs in other systems, that's extremely useful in certain scenarios.
Yeah, absolutely.
But yeah, we've seen, I guess in our organization, probably most we've seen the Internet of Things side of things. So this would be covering the sensors and GPS tracking and SCADA and things like that. So that's where we've seen. But maybe if you could comment if you've seen event streams in other areas, that'd be super interesting to hear about. We can talk about that at the end.
Yeah, absolutely. So good. Yeah, I mean, and industries benefiting from stream data. Here are just some examples. Utility companies, of course, monitoring their network. Energy companies, again, interested in their infrastructure. Telecommunication. Transportation Steward had a good one, monitoring the flow of vehicles through your highway network. And we see this in all cities now. You'll drive into a city and it will give you estimated times to go places. And then if you know the city, you can decide what route you're going to take. I know when I'm driving into Vancouver, I get those real-time, there's a billboard on the road, and sometimes they'll take Highway 99, sometimes they'll take Highway 91, depending on what I'm seeing. And of course, the GPS is in your car now, are getting that information too in real time to try to maximize the efficiency of the road. Governments, oh man, yeah. So they are responsible for, improving the lives of their citizens. And so there's so many things they can do there. Healthcare could be healthcare in terms of inside a hospital, but it could also be healthcare in terms of just the personal devices that you wear that help you understand your own personal health. So, and businesses like this coffee shop here are, if they know what's selling today and what's not selling today, they can try to promote lower the price to try to get it out so that by the end of the day it's all gone. I mean, there's just so many things you can do with real-time data. Yeah, and I like this order because operational efficiency is something that every business is interested in. If you can in some way use real-time data to improve the efficiency of your operation, that's just going to go right to the the bottom line, enable you to hire more staff, to increase your reach of your tool, to improving, the customer experience. It's definitely the connection between organizations that are run efficiently and customer experience is going to be a high correlation. So that's super important. A lot of us at SAFE, we go skiing, not this weekend, it's been closed, but and if you're skiing and the ski lift will tell you, sometimes again you'll see poles with numbers of the expected weight at each ski lift. Well, the better you can do that, the better your customer experience is, and also the more efficient your operations running. So again, being able to use real-time data for that, asset management, and also asset utilization. If you have one part of your business that's constantly overloaded, and you could let people know that, hey, if you go here, you're actually going to get better service. Vancouver Airport has that. Like when you're flying domestically, they have gates B and C, but then they also have D. And sometimes they'll tell you, even though you're at the BC line, they'll say, hey, go to gates D because the lineup's actually shorter. And again, increases the efficiency of the asset usage. And situational awareness, there's many examples of that. Forest fires, fighting any emergency, knowing where your crews are relative to the fire can save lives, because you obviously want your crews in there to fight the fire. But if the wind changes, then you want to know where your crews are relative to the fire so you can get people out, and just understanding what's going on is huge. And medical care, monitoring medical equipment, from the health of the equipment to sensors on patients, so that they send you things when patient changes rather than having to go in and check, to our Fitbits and other devices that we have on our wrists that help us understand our own. And these are just some of them. We could talk for an hour just on this.
Yeah.
This is one slide. Yeah, absolutely.
I think when we were running through this yesterday, we were chatting a little bit about the kind of pairing together transactional processing, batch processing with stream processing as well. And the smartwatch is a good example of that, because the watch might be collecting data all the time, say on your heart rate.
Yeah.
And events might go off when things happen, like a high heart rate or something like that. But then in the background, you could well be gathering that data, and then you can run queries against the data to tell you things like, can I detect a pattern as to when someone's going to have a heart attack based on the data, and things like that. So there is a place for both, right? For batch and stream processing. They're kind of different. They deliver different value in a way.
Yeah, absolutely. So it's good.
So this slide I just kind of threw together because before we talked a lot about the sources of stream processing and events in terms of what might be generating them, but this is just a little look from a different perspective, which is when you're building out an architecture, where might you need to connect to get all of these unbounded data streams?
Yeah.
And the thing is here is you might not have control about what you're connecting to. I mean, we see this time and time again. Often as an architect, when you're building out your stream processing framework, you're just told you need to connect to this endpoint.
Yeah.
You don't have control over that part. So these are some of the technologies that you're going to run into, kind of grouped by protocol.
Mm-hmm.
MQTT, AMQP, 1 and 0.91. We've got Kafka, which has become hugely popular in the last few years. Kafka's more of a platform. The others are slightly a little bit more lower level.
Yeah.
And then we've also got proprietary cloud offerings as well, that are kind of tied to the specific cloud. So it's a bit of a minefield.
Yeah, exactly. And we don't, these are the most popular ones, the one we've seen. If there's other ones out there, when you start down your journey on data streaming, or you're there now, let us know, because we're not talking about product here, but data streaming, being able to connect to the data streams, both reading and writing, obviously is a key piece to any real-time data stream technology. So if you take a look at ours and then you see, oh, gee, I wish they had, a particular data stream technology, let us know, because no way are we done adding them. Yeah.
And I think it's very rare that you're going to connect directly to the sensor. Like in most architectures, the sensor will write to one of these queuing protocols, and then you'll probably connect to that. That's almost
Absolutely.
global kind of architecture.
Yeah.
Okay. So I think we've got a quick poll here that Steph's going to pop up for us. So is your organization leveraging or planning to leverage streaming data? So if we could answer that here, I think there's a few options there.
Yeah, and let us know where you are in your journey, or you're here just to understand what streaming is, and you're just in the, the ideation stage. Then let us know that too. But it's a pretty exciting new area for sure, and we're just seeing explosive growth. So yeah, it's going to enable a whole new set of solutions. So.
Yeah.
Awesome. Okay, I think I'm going to close this down in like 3 seconds, so get your last answers in. All right.
So, wow, look at that. So 36% are currently leveraging streaming data. That's awesome. And yeah, that's really great. And then another third in 1 to 2 years. So good. And do reach out to us. It would be great, if you're using streaming or not, even what of those streaming protocols, for example, are you using, and also, what industry are you in? And the more we understand, it's just such an exciting area. We just love to engage and learn more and that sort of thing. So yeah, so thanks for that.
That's great, interesting.
Very good.
Okay, so now we're going to actually dive more into the stream processing part.
Right. Yeah. So stream processing really is the term that we use to group together, the ability to collect, integrate and analyze this unbounded data. And the goal of stream processing, of course, is so that organizations who embrace it are able to get insights on a continuous basis. So rather than having to wait when a batch job runs, or at the end of a day or the end of a week or end of a month, looking for trends, being able to, react on a immediate basis. Yeah. And really, there's 3 types. One is batch stream processing of stored data. And this is really, you don't have a true data streaming solution, or the only way you can get access to the data is it's delivered in batches. And so this isn't real time, this is near real time, and it depends on, that specified interval. Is that a minute? Is that a second? Is that an hour? And but sometimes that's the best you can do, or you don't have data streaming, and so we would consider this near real time. Yeah. The next one is event processing, and this is when the real-time events are delivered at a low velocity. So it might be once a minute, once an hour, but once the event delivery starts approaching, an event per second or sub-second, then really this event processing starts to break down. And and then you need the stream processing, which is continual. And this can go high velocity, low velocity, whatever you want. And with our solution, in our dynamic engines, you can do really low velocity or really high velocity. Or sometimes you have streams, as Stuart mentioned, where at some points during the day, it's really high velocity, rush hour. So data is being delivered super fast, to very low velocity, where, middle of the night, you can literally, you might have a car go by every 15, 20 seconds. And this is what we're talking about today, is the stream processing. And this is the one that we're super excited about, as far as our technology goes in the latest release, is being able to process millions of records, a second is super exciting. Yeah. Yeah, and when we look at the differences, you know, and the frequency, you know, I alluded to that in the previous slide. Batch is, you know, great for you know, trends. The jobs are run infrequently, often on a schedule. They might be daily jobs or weekly. Whereas stream, the job's always running. It never ends, as Stuart says. You imagine that you connect to some data stream, it never ends. So the processing is continual. And you don't really have any control when the data arrives. It just arrives when the data is being collected. And so, you know, the latency difference is huge. A batch processing, you know, it's measured in minutes. It might be half a minute up to hours or quarters. So very high latency. And so you're going to have to wait until that batch job runs. Where stream processing, depending on the use case, you know, you might get the data within a second it's collected. You might get a data in a millisecond. And in some cases, there's, you know, organizations go to high effort to deliver the data to the processing as quickly as possible, because even milliseconds can matter. Where in others cases, it's seconds. So the latency depends on the use case. And data sources, of course, batch processing, the data is stored somewhere. Could be stored in a database or available through a REST API on top of that. Where stream processing, it's coming out of, you know, a message queue. When you look at the types of processing, of course, batch, it's scheduled, and so you can do really complex trend analysis, you know, and things like that. Whereas stream processing, the data is coming at a high velocity, so generally it's much simpler analysis, because processing, of course, takes time, and you only have so much time. And you know, maybe you have some systems like ours where you can do things in parallel and ensure the stamp properly, but still you're going to do less processing in general. And batch processing is generally always after the data is stored. Whereas stream processing, you process it and then maybe you store part of it, maybe you store all of it, maybe the storing is happening at the same time as you're processing it. But definitely the first highest priority is to process the data as soon as you can. Yeah.
Mm-hmm. I saw one article, probably they take the latency to the extreme is the financial sector, and they're building data centers actually as close to the exchange as possible to get the latency as low as possible. But I think most of us won't be looking for that kind of latency. But
Yeah, and the last thing we should say, Stuart, is that you need both in an organization. We're not saying here, hey, you're going to throw out your batch processing for stream. They're solving completely different problems, right? Batch processing is great for analyzing trends, whereas stream processing, you know, for analyzing and working with the single event at a time. So yeah,
exactly.
Yeah.
Okay, so let's talk about how we do analyze unbounded data and data streams in stream processing. Now, as Don just talked about, when you're processing data from a non-streaming data source, like a database or file, it's easy. You know, the data's at rest. You can load the data into memory and then sort and group and do what you need before analyzing it. You can't do this with a stream, because it's infinite and it effectively never finishes loading. So this is where windowing comes in, and windowing is a technique that allows you to break up the stream into groups for processing, and it does it based on time. So let's go back to the vehicles moving throughout a city in rush hour. So maybe this is the stream on the left here. The dots represent all the vehicles. Let's say you want to calculate an average speed for a 1 minute window, because if you were to save the data for every single one of these points, maybe there's 50,000 points every 10 seconds coming in. That'd be a lot of storage. So instead of saving all of that data to disk, what we can do instead is, over a 1 minute period, take the average speed maybe across a bridge or a key piece of infrastructure, and then we can do analysis in that window and then save that to disk. So when you're thinking about windowing, what you need to do is you need to choose a window that's representative of kind of the outcome that you want. So if your window's too small, as in maybe, you know, you drop it down, or I'll do it for 30 seconds instead of a minute. well, then you won't have enough data in that window for it to be statistically significant. But if you make it too big, then it's not, you're losing the real-time component, because yes, you're going to have more data in the window, but then you have to wait longer for the output. So this is an interesting thing you'll have to play around with when you're building your stream processing architecture out. So what we'll do now is kind of take that last point there about windowing, because we're going to look at an overview of core stream processing workflows here. So again, Don and I we've pulled these 4 things out, but this isn't representative of every type of analysis you can do with stream processing. It's just the kind of key ones that we've seen. So the first one is pretty simple. It's reducing data volumes in memory before committing data to disk, and that's filtering the stream. So 2 types of filtering here. One can be a simple attribute filter. So imagine all these vehicles coming in rush hour. Maybe you've got a couple of thousand points a second. If you store all of that to disk, that's quite expensive to do that. Maybe you're just interested in a certain type of vehicle, say an SUV or a large truck carrying goods. You can filter that data in a workflow and then commit that to disk. Another one would be filtering based upon location. So we might be collecting data for, say, the whole of British Columbia, but we only are interested in doing analysis on the city of Burnaby or city of Vancouver. So in this situation, you can filter the data based upon location. And this is an interesting point, because I think this is quite common, because a lot of times organizations, they want to use a data set that they don't own. So it might be a data set that collects, say, data for really broad scenarios, but they're only interested in one scenario. So filtering's a really important thing there.
Yep. The next one, enriching, and this is, again, a key point. Let's say we have temperatures on particular pumps, and they're coming through in a stream, but the information about the pump is actually in our database. So every pump has an identifier, so it has the identifier and a temperature. Then what we could do is connect to the database with that identifier and find out the operational range of the temperature of that pump. And then using that information, then we'd be able to decide if this pump is in trouble or if this pump is operating normally. So, and again, it's a situation like that where the data coming from the sensor doesn't, we want those messages to be really small. So sometimes to get them really small, all the information we need to actually make decisions isn't on each sensor. So by connecting it to the database and then pushing the enriched data downstream, enables us to make intelligent decisions. So that's enriching.
Nice. So the next is aggregation. So summarizing and creating kind of statistics on the unbounded data. So in this situation, you do need to use windowing to do the aggregation, because you need to kind of create a beginning and an end to do the analysis. So a couple of examples. One, again, let's say we have we're tracking vehicles in a city and we want to get the average speed northbound and southbound over a bridge. So we don't need the average speed in real time. What we can do is maybe gather all of the vehicles within a 60-second window, and then we can calculate the speed of those vehicles and then save that to disk. So when you do this aggregation, you hugely drop the volumes of data that you need to store. Another example might be, if you're monitoring air temperature with thousands of sensors across maybe a province or something, you don't need, let's say the sensors are being built for one situation where they need second-based reporting. Well, if you're writing the data out to a BI dashboard or something, you probably don't need that level of granularity. So again, you could aggregate the data maybe over a 5-minute period or a 10-minute period, and then write that data out. So this is another good way to kind of reduce data volumes.
Yeah, and this event detection is, we talked earlier about the difference between real-time event systems and real-time streaming systems. And so this kind of ties it together. For sure, you can go from streams to events, but you can't go from, and I'll give you an example. Let's say we have an event stream going, that's again our pump temperatures. We use an enrichment, then we use a filter, and we determine that this pump's in trouble. So at that point, what we could do is trigger an alert and then, or an event, and then that could even go to our event system for further processing at the event level. So from streams, we could go to these events like pump overheating, and the idea there is you want to replace that pump before it fails. But you can't go the other way. You can't go from pump fails to then wanting to know, well, what was the, what was the temperature readings of that pump just before that event was triggered. So, this is just tying them both together. And again, when you're looking at real-time systems, you're going to want to look to see, does your system support both streams and events, and how easy it is to move from streams to events. Yeah.
Interesting. Yeah. And I think so. Now what we want to touch on is the geospatial part. So I think in every example Don and I just talked about, geospatial could have been intertwined and leveraged, and that's really the point now, is that a lot of real-time data now has a geospatial component, and I know you've been doing a lot of the indoor mapping, so it's not even just outdoor data now, right, Don? It's indoor as well.
Yeah, when you think of every event happens somewhere. So maybe in the past you'd have a sensor number, and you'd have to go look at a book to figure out exactly where it was. But now organizations, whether it be indoors or outdoors, they expect to look on some dashboard and see the thing generating the events in context, right? Like, where is it in my building? Show me a picture. Where is it, on the surface of the earth, and things like that. So location is just so key. Yeah.
And we've picked a few out here, haven't we? A few key use cases. There's lots of them, but I think these are the most kind of prevalent that we're seeing when working with stream processing.
Yeah.
The geofences, some people call them buffer, creating a buffer as well. This is really at the core of a lot of spatial analysis, but it's particularly useful for filtering data streams.
Yeah.
Proximity.
And fences might be moving too, right? Like the term fence in our mind, it's like they're like in the ground, but these fences those might be geofences around a moving asset, and you want to know when that moving asset is coming close to a different type of moving asset. And so so it's interesting.
Yeah. Proximity analysis. So in Vancouver on, I think, Sunday night, we had winds over 100 kilometers an hour, and all trees were down everywhere, electricity was out. So how does the city distribute vehicles to events that have happened throughout the city? Well, it'd be really useful to do proximity analysis. Which is the closest vehicle to this power outage center? And you can distribute vehicles more efficiently in your network than when you're using location. Snapping data to a network. So this is data cleaning. We've seen this one. So let's say GPS has an error of it's a couple of meters, but it can be a lot more, can't it, in downtown areas. But if you want to clean your data before you write it to disk, you can snap the data to the network, so to the road network, and then write the data to disk, and then your data's all clean.
And calculating distance, of course. Again, going back to, you report a gas leak and the utility company wants to dispatch a vehicle. It won't be the distance that you're interested then is not how the crow flies. It's the distance on your road network. And so again, the ability for real geospatial processing that can take into things considering like road networks and things like that, that can really be key. And with sensors and calculating distance for response.
Yeah, and obviously all of these have to be fast. They need to be performant when you're working with high volumes of data for any system you choose. Okay, so now this has come up a few times, so we thought we'd include it. You know, what's the role of cloud computing when it comes to stream processing, and do you need cloud computing? Do you need to leverage cloud computing, basically?
Yeah.
I think the answer here is yes. I mean, technically, you don't have to, but if you didn't, I mean, these are some of the services related to stream processing that you can leverage. I think if you didn't, you'd have a significant cost.
Yeah, and I think anybody designing new systems nowadays, or any new business, no matter how big or how small, you would start now with the cloud. You wouldn't. I can't imagine, you building, on-premise infrastructure, unless, of course, there was a security need, right? Like you're in manufacturing, and that the equipment needs to be really, really close, and you're not even connected to the outside world and running. But in general, and if we look at we go back and we look at that slide you had, Stuart, people flip back later, they'll see that, a lot of those sources of streaming data now is in the cloud. I mean, the scalability of these is just, phenomenal, right? And you can focus on your problem. You never have to focus on, the infrastructure. So yeah, clouds is where it's at. Definitely, yeah.
Yeah, and to handle those, peaks in traffic as well, that variability, you need the scalability of the cloud. Otherwise, you're going to overpay for your infrastructure.
Yeah.
But they're even
actually learning. I mean, boy, oh boy, you just look at the machine learning services as well on, pick your cloud, and they're constantly getting better. So the machine learning service you hit today and the machine learning service you hit tomorrow, it might look the same, but it's probably better, because these things are constantly. And that's, an overlooked thing about the cloud, right? Is you're never installing a new machine learning thing from Amazon. It's just, or Google or Azure. It's just always improving, and you're leveraging off the great work that they do. Yeah. So, and again, when you're looking at your streaming solution, you want to really look at one that embraces things like serverless and all these, scalability solutions of these different cloud services.
Yeah. So if you are going to do this on premises without cloud, I mean, there's lots of open source tools, and we'd love to hear from you, because I think it'd be a fascinating story.
Yeah, it would be very expensive. You're going to need, but be very interesting. Yeah, so Stuart, I mean, hopefully our goal here was just to give a very high level, set the, a base level of knowledge. So when we're talking about stream processing, people understand what we mean by it. And really, it's a great time. The whole stream and sensors and data are just exploding. And it's with 5G coming online, and we're just going to see more and more data from all over. Yeah.
And I think to complement this webinar, we've got another one next week.
Right.
So this one will be much more looking at how we can leverage FME, our technology, to work with data streams. Lots of demos, lots of workspaces, showing the new FME server streams workflow. So you can sign up for that at that website.
Yeah, very, very good. Yeah, and and don't forget, everybody, the World Fair. It's a FME World Fair, so we're going to highlight, all the great things that users are doing with data. So there's users from around the world who are going to share their, ingenious solutions that they use, how they use FME to make their businesses run better. It's from May 4th to 14th. I believe SAFE goes from the 4th to the 7th, and then we have partners from around the world. Everything's recorded, so if you register, even if you can't attend something at its scheduled time, everything's there. You're going to hear more about our stream solution. You're going to hear about roadmap. You're going to hear about the latest releases of FME, and there's prizes, of course. You can win swag and all these sorts of things. So please do register, and even if you just want to scan and pick user stories and things like that, at your leisure. So it's a little over a month. Hard to believe.
Yeah, it's going to be great.
Yeah, it's going to be fun.
Are there any questions we want to, Steve, has anything come up that's interesting? Okay.
It's been quiet. Yeah, it's been quiet on the questions. So I think what you guys shared was a great introduction to the subject, and I think next week we'll be a little busier with the questions.
Okay, thanks.
Absolutely. So, yeah, so thank you, everybody. Thanks, Stuart. Thanks, Vivian.
Yep.
Thanks to everybody. Thanks, Megan. Thanks to everybody at SAFE who helped us put together. Thanks to Laura and Steve, and who else is on the call helping us?
Mark.
Mark, yeah. And and do follow us on social if you want to, learn and follow all the exciting developments at Safe Software. Then then please do connect with us on Twitter, LinkedIn, Instagram, or YouTube. So yeah.
Bye-bye.
And your blog, Stuart, was a good one.
Nice.
Oh, yeah.
I did see one question coming quickly that says, what enhancements does FME 2021 provide to better support streaming workspaces?
So I mean, lots of things coming in 2021. Firstly, there's a lot more connectors. So when you look at that diagram I showed earlier, we actually support most of those in stream mode now. And then we've got, you want to talk about the server stuff, Dom?
Yeah, and FME server now, streams are front and center. So when you see, you're able to log on to FME server and see the streams that are being served, what workspaces are being run on those streams, and what engines are assigned to those streams. We've also made a sweep through the FME engine to ensure that it can support this unbounded approach. So in the past, there's been some places where we would wait till the end to do all the grinding. Now, with the time windower, you can stamp things going by for the correct time window. And regardless of what you're doing, it'll be processed time window by time window by time window. And so lots of changes, huge effort everywhere from the server side to Stuart's team, building all the connectors and making the changes. Stuart's team also made the changes to the server, to the entire engine team that had to, make sure that they now thought about unbounded data flows. So yeah, so it's been massive changes. We're taking the whole streaming initiative very seriously, and we're super excited to see, A, what users do with it, and B, what they want us to do next. Because like anything with FME, it's a journey, and this journey is just starting. Yeah.
Definitely tune into next week's webinar for the answer to that question too. That's the whole point of next week.
Yeah, exactly.
Absolutely. And for that one, you'll have Stuart and Dale. And so Dale and I are tagged. We're both so excited about streams. We're tag teaming this one. So,
we had to share the wealth.
We had to share the glory. That's right. And Stuart, of course, is the consistent one because he led the entire effort. So good job on Stuart and his team. Yeah.
And then I think there was a question earlier that said, does this webinar pertain to FME server or FME cloud?
FME cloud is where we host FME server. So the answer is yes and yes. So if you launch an FME cloud instance and you pick the latest FME server, then you'll have access to this. If you go on the Azure marketplaces or the Google marketplaces and launch the latest FME server, you'll have this. So the answer is yes.
Awesome. Then
we have a non-streaming question. I wonder what that is.
Yeah.
Oh, we just got another question that popped in.
They're all coming in now. Let's have a look.
People get brave.
There's a bit of a lag between the Q&A when the questions come in. Sorry, Steve, go ahead.
Yeah, this question here just says, is it possible to change the data capture between two SQL databases with stream processing? That's an interesting one.
Yeah, I haven't thought about that. Is it
Could you use like triggers? Is that what I mean? Like triggers on the...
Well, some of the logging of the database itself, you could also potentially interact with that maybe. I'm not sure about this. Yeah.
Because you could have a trigger, Stuart, yeah, and every time a trigger fires, it publishes to a stream so that then you can capture, data from one SQL database and then push it to another to do real-time replication, if that's what they're getting at. Making sure a change on one database is then pushed immediately to another, so you could do that.
interesting.
Yeah. So, and yeah, and so for people to reach out to us at SAFE, there's lots of ways. There's live chat. There's LinkedIn. So so Steph, I guess when everybody will get an email, and part of that is how to reach out to us for more. And we're always happy to talk. So if anybody's beginning their stream processing going and they want to just learn more, we're happy to engage them. Yeah.
Sure, for sure. I'd say definitely reach out on live chat. Go ahead and add Stuart on LinkedIn.
Yeah.
Stuart and John. And we have the FME community as well, which is a great way to reach out to not only us, but like so many other FME experts. I can't even tell you the knowledge that's out there. So definitely join the community and continue this conversation in there. I think a lot of people would really be excited to join in on that. Okay.
Perfect.
Great.
I think then we're probably good on the questions. So Stuart, we'll see you next week.
Yep. Thanks, Steph.
Awesome.
And thanks everybody. I'll be watching next week. So take care. Yeah, bye.
Done. Bye everyone.